All right, so that was basically how to do it. Isotopes, not really a big deal. Another idea, like I said, we're moving through these pretty quick, is this idea of you have a molecular formula and we have an empirical formula. All right, so you have a molecular formula and an empirical formula. A molecular formula would be something like H2O2. That is hydrogen peroxide. Hydrogen bonds to the peroxide, polyatomic ion. Its empirical formula would just be HO. Basically, what an empirical formula is, it's the lowest whole number ratios. So this is a 2 to 2, but the lowest whole number ratio would be a 1 to 1, so it's HO. That's the empirical formula. If you're given something, let's say like C2H6, that of course would be its molecular formula. CH3 would be its empirical formula. There's problems that we have done in class before. I don't want to go through the whole thing. It's not that hard to do, but basically you'll get something that's like 20% of the mass of something is carbon, and I'm just gonna make this up as we go. 10% of the mass is hydrogen, and then you end up getting like 70% of the mass of something comes from oxygen. So I don't know if you guys remember how to do these, but basically the question says is, oh, okay, what is the empirical formula? CX, HX, OX. We want to figure those things out. So what we'll end up doing is we'll take this 20% carbon and we're going to pretend we have a 100-gram sample. So I got 20 grams of carbon, 10 grams of hydrogen, 70 grams of oxygen. And if you notice, it's O, not O2, because this is not diatomic oxygen, it's the oxygen that's up here. Now, what we need to do is, this is saying whatever number of carbons to whatever number of hydrogens to whatever number of oxygens. So we can't use masses, but if we change it to moles, we can then compare how many of each we have. So what I'm gonna do is I'm gonna take my 20 grams of carbon, my 10 grams of hydrogen, my 70 grams of oxygen, and I'm gonna convert them to moles of carbon, moles of hydrogen, moles of oxygen. And so then what I would do is I'd go through here and say 1 mole of carbon, I'll look up there on the periodic table, is 12.0107 grams of carbon. I would say my 10 grams of hydrogen, well, 1 mole of hydrogen, you look up there and it's like 1.001 or something like that. And then my 70 grams of oxygen, 1 mole of oxygen weighs 15.9994 grams of oxygen, grams of hydrogen. What's that gonna do? We do the math and we're gonna get our moles of carbon, so some number of moles of carbon. We're gonna get some number of moles of hydrogen and some number of moles of oxygen. Hope you guys remember this. Now, the very next thing you're gonna do is we're looking for the lowest whole number ratio. So if I told you that in the class there were 20 blondes, all right, and that there were 15 redheads, and that there were, I don't know, say 10 brunettes. Well, how would I go through and figure out what's my actual lowest whole number ratio? I'm gonna take my smallest number here and divide each one by my smallest number. And so I'd get 2 blondes, I would get 1.5 redheads, and I would get 1 brunette. Now, there's no such thing as a half a person. And so I'm gonna take these numbers and multiply them by some number to get me to a whole number. So this 1.5 needs to become a 3. So multiply that by 2, so I'll get 3. So multiply by 2, by 2, by 2. 3, 4, and 2. So this was my formula here. What I would do is I would say, oh, I've got 4 blondes, I've got 3 redheads, and then I've got 2 brunettes. That would be my lowest whole number ratio for this right here. So we go back up here, and once I have found my moles of carbon, my moles of hydrogen, my moles of oxygen, I'm gonna do the same thing. I'm gonna divide by the smallest of them, and that will get me my moles of carbon, my moles of hydrogen, and my moles of oxygen after I divide by the smallest one. And then if I need to multiply, I'll multiply. So let's just say, for instance, this is 1.3, this is 2, and I'm not saying this is what it's going to be by any means, and this is 3. Well, then I look at this and I go, oh, I'll multiply that by 3, and then all of these by 3. So if I multiply that by 3, that would be 4. If I multiply this one by 3, that'd be 6. And if I multiply this one by 3, it'd be 3. So that'd be my lowest whole number ratio. My formula would be, if that was it, which it's not, C4H6O3. This is my empirical formula. Now, the very next thing they might ask you is, what is the molecular formula? So they're going to give you some molecular weight. Some molecular weight. Well, okay, so it's going to be some number over here. So let's just do this real quick. So let's say this is my empirical formula. My empirical weight would be 4 carbons, that's 48, plus 6, plus another 48. 16 times 3 is 48. So I have 96 plus 6, 102 grams would be my empirical weight. If over here they had told me that the actual molecule, the actual weight of the molecule was 306 grams, well, then I take my empirical weight and figure out how many times I need to get there to my molecular weight. So that, of course, would be multiply that by 3. So that means my actual formula would be C12H18O9. And you see, as long as I keep the same ratios there, a 4 to 6 to a 3, a 12 and 18 to a 9, then these guys are legitimate with each other. And so once again, all I simply did was, if I find out the percentage, change it to 100, change it to moles, divide until I get myself, divide by the smallest until I get myself some lowest whole number ratio. And then I take my empirical formula, find the empirical weight, and figure out how many times it goes to the molecular weight, and that gets me my molecular mass. I know that was fast, but we've done this already.